So you've done a lot of solving linear equations before, but have you ever thought about it in a very general sense of how it relates to the definition of a function? Whenever you solve an equation, you essentially figure out one of those sets of ordered pairs that belongs to a certain function. So solving an equation can work a couple of ways. Let's use one function for an example. We're going to use this little linear fellow, 3x plus 4. Now, someone might ask you, solve for when x equals 2. Now that's pretty straightforward. They're giving you one part of your ordered pair and asking you to figure out what is the other piece of the ordered pair that is going to belong to this function. So we can say f of x equals 3 times 2 plus 4. We're substituting 2 for x because we know that that's the x value at one of these points. So f of x equals 6 plus 4, or f of x equals 10. So that second point equals 10, and you know that the point 2, 10 is part of your function. Now the other sort of solving that you can do is to solve for the x variable if you're given the function variable. So you might run across this. Now you say, oh, duh, that's a single variable equation. I can solve that easily. But remember, this is a function, one variable of which you know, the other of which you're going to find out. So the game here is what is x when f of x equals 13. So in this case, you already know the second set in the ordered pair. You want to figure out the first one. So 13 equals 3x plus 4, which means that 9 equals 3x if we subtract 4 from both sides, or x equals 3 if you divide both sides by 3. So the point 3, 13 is an ordered pair that belongs to this function, and the point 2, 10 is an ordered pair that belongs to this function. Whenever you are solving anything, you are figuring out what one variable is given some sort of contingency, given some sort of other variable for the function.